Okay, great. Hello and welcome to the first class in the digitization series offered by the Library of Michigan. I'm Biz Gallo, the statewide digitization initiatives coordinator, and my job is to help libraries and cultural heritage organizations around the state digitize their collections and make them accessible. So in order to help prepare the state to do so, we've created this 9-part series that will help lay the foundation for digitizing your collections. You can see a list of the other classes in the series on the right-hand side of your screen. These are held the last Tuesday of each month at the same time, and Becky's going to go ahead and drop the link to that registration in your chat if you want to register for the other classes. You can register for all of the courses or only the ones that are of particular interest to you. If you want to learn new skills or if you just want to use certain classes as a refresher, it's completely up to you. And then after the basic series, we're going to be offering some more in-depth classes, both on the topics covered in the basic series, as well as a variety of other topics. We'll have some format-specific classes, such as digitizing newspapers, audiovisual material, and scrapbooks. We'll have some resource-centered classes, like working with vendors, working with volunteers and interns, and building community archives. Then we'll also have some procedural classes like writing digitization grant applications or creating digital exhibits. I also want to extend that if there's anything that you're particularly interested in learning more about, to contact me and let me know so I can help develop more programming and services around those topics. In addition to the Digitization Basics webinar series, we'll be developing niche modules from the material covered in this series. And that way you can hone your skills and earn badges in digitization. So a little bit of housekeeping. This webinar is being recorded, so you can access the content again later, along with the slides. These should be available to you sometime next week once they've been transcribed, and Becky will be emailing those out to you. There will also be time for Q&A at the end, but if you have questions throughout the presentation, feel free to drop them in the chat, and Becky will be monitoring and collecting those questions, so we'll be sure to answer them at the end. If you have any technical or audio issues, please feel free to contact Becky. You can send her a direct message. She'll be monitoring the chat and can resolve those for you. If you are really excited and want to get ahead and learn more about digitization, you can always check out the Library of Michigan's digitization page on our website. That is michigan.gov/lmdigitization, and Becky will also drop the link to that in the chat. You are muted, but feel free to unmute yourself at the end so we can, if you have questions to ask or if we get into a discussion, I'd love to hear from you. So in terms of today, the topics we're going to be covering are what is digitization and what it isn't, reasons for digitization and maybe some reasons against it, as well as terminology. Some of what I'm covering today or throughout this series may be above or below the level that you're at right now, and that's okay. If what I'm talking about is too basic, I get that. This is a foundations class, but I'm sure there's at least something new you'll learn today, even if that's just about some of the services and programs the Library of Michigan offers. If what I cover is over your head or too technical, I get that too. Please don't worry. I know that digitization can seem conceptually abstract and intimidating, but you're not going to be tested on this. However, I do hope that you come away with at least a basic recognition of key terms and concepts so that the next time you hear them, you'll say, oh, I remember that, or that sounds familiar, and you're not going to be starting from scratch in some of the later classes. Okay. So before we get started, I'm going to launch a poll. And so Becky, if you can go ahead and launch that, I'd love to get some feedback. What is your #1 reason for not digitizing material in your collections right now? Got time, expertise, funding, lots and lots of answers coming in. Looks like time and expertise are pretty close. Give it another minute. Okay, great. So it looks like time is the #1 answer, followed by expertise and funding and equipment. And one of you is currently digitizing material in your collection, so good for you. Okay, great, thank you. So Becky, if you want to stop the poll, and then we'll move on right now. Great, all right, let's get started. So for those of you who answered expertise, we're going to start tackling that today. let's start by exploring what is digitization. When we talk about digitization, first and foremost, it's a process. It's a process by which analog information is converted to digital form. But what does that look like? Is it taking a picture of a document with your smartphone? Yes. Is it scanning a photo on a flatbed? Definitely. Is it transferring music from a vinyl disc to a CD or MP3 file? Yes. This is what it normally looks like. Usually, it's information stored in analog physical formats, such as paper documents and photographs, but it can also be analog electronic formats, such as audiovisual material. Records can be digitized via scanning or photography, or via the conversion of analog audiovisual information into bits. Beyond technical definition, digitization is also a tool to help support the broader work of libraries by enhancing learning and increasing access to information. We'll look a bit more at the ways it does so in our next section, but it's important to understand that just because something is digitized doesn't mean it's accessible or preserved. Over the course of this series, we'll be focused on creating digitized materials that adheres to standards and best practices to ensure that they will be preserved and accessible for as long as necessary. Okay, so now that we know what digitization is, let's look at what digitization is not. Digitization is not a panacea. People often think that once something is digitized, the work is done, that everyone can access the digital files and they are preserved, when digitization is really just the beginning of the digital life cycle. Just because something is digitized doesn't mean it's accessible. Even in digital form, objects need additional work to make them accessible for those with disabilities. Once files are accessible, they need a platform through which to be accessed. Even if digital collections are online and in an open and accessible way, not everyone has access to a high-speed or reliable internet connection. Again, digitization is a tool in your toolbox. It is not a cure-all. Digitization is also not preservation. Digital files require even more attention and effort than their analog counterparts to ensure their usability over time. If I stick a photograph in a drawer and come back 20 years later, all things being equal, that photograph will likely still be viewable. If I save an image file to a hard drive and come back 20 years later, a lot more work will be involved in accessing that image. Does the hardware work? Is that file format still supported? Was there bit rot or file corruption? The steps you take today when you create digital files will help you ensure that they can open that image file 20 years in the future. Remember, digital preservation is another part, an essential part of the digital life cycle. It requires managed attention and resources over time to ensure access. All right, great. Now that I've scared you all away from digitization, we can go home. Just kidding, or at least I hope not. For as much as digitization is not a perfect solution, there are several benefits to digitizing material that can outweigh the costs. Let's take a look at the three primary reasons to digitize your collections: access, preservation, and revenue. All right, I'm going to ask for a little interactivity right now. Why don't you go ahead and drop it in the chat which one you think is most accessible or more accessible to most people? A, an audio cassette tape, or B, an MP3 music file? B, lots of B's, 1A, lots of B's, okay. Couple A's, couple people still have some tape decks in there, okay. All right, let's move on to this example. A physical document, or B, an OCR text version of that document? This one's about 50-50. Lots of A's, lots of B's. And the last one, A, a VHS tape, or B, streaming a video online? This one's unanimous. Okay, great. Thank you all for participating in that. All right, so for most of the examples, the digitized version would be more accessible. That's what digitization does. It facilitates access. As I mentioned before, digitization is not the same as access, but it removes many of the barriers to access that a physical items can have. For many organizations, access is the driving force behind creating digital collections. For most users, it's easier to explore a digital collection on a website than it is to travel to a location, pay for parking, make an appointment during often limited hours, if they're even open at all these days. Sometimes you have to request items days or weeks in advance of a visit, and that's just for users. What about the staff working with this material? Over the past 2 years, we've seen the benefits of having digitized collections as they allowed access when physical spaces weren't safe. People expect this kind of virtual access to collections now, and will need to create digital collections to meet those needs going forward. Okay. This is all assuming that some materials are even available for physical access to begin with. Even pre-COVID, digitizing fragile items increased access to otherwise hidden collections. There are always items that are either too fragile to handle or put on display, or media and formats you don't have playback equipment for, or less popular collections that don't make it into an exhibit, but still have research value. By having a digital surrogate, you can provide access while protecting the original. Digitization can also help improve accessibility. Tools like optical character recognition, or OCR, can make a handwritten manuscript accessible using screen reading technology. SRT files in audiovisual material provide closed captioning for deaf or hard of hearing users. Using available technology to augment digital surrogates can open up content that was once inaccessible or less accessible in analog form. These accessibility features also make collections more discoverable for a wider range of users. Last, by expanding access and utilizing these technologies to transform images into data, that data can be parsed and used to improve and facilitate research. The creation of high-resolution scans enables analysis beyond the capabilities of the human eye. And digitization allows for the creation of digital exhibits that might otherwise have been impossible in a physical space, whether within your own building or by collaborating across multiple institutions. The second incentive for digitization is that it facilitates preservation. Modern history and art have been recorded on more and more fragile media. Paper yellows and becomes brittle, acetate shrinks, polyester gets sticky. Traditionally, digitization for preservation has meant addressing carrier obsolescence and degradation. Sometimes we can stop or reverse these sorts of issues, but most often digitization is a way to preserve the essence of an item before it's completely lost. For example, all analog video is now obsolete with playback machines no longer being produced. Digitization preserves the essence of these deteriorating or obsolete media when their originals no longer can. Digitization has also offered a surrogate in the event of theft or vandalism, while allowing these materials to be accessed without worrying about additional protective measures around the original. Finally, with the worsening effects of climate change, we will continue to see flooding and damage like we saw during the Midland floods. Between flooding, fires, and other disasters that can wipe out physical collections in an instant, digitization is a way to prevent total and catastrophic loss. The third main incentive for digitization is that it can be a source of promotion or revenue. Maybe you're digitizing material to promote an exhibit. Maybe you're going to be posting pictures on your website or creating printed materials. Maybe a researcher wants to use a high-resolution image for their book. If your own organization wants to use those images for postcards, booklets, t-shirts, or more to sell in your gift shop, you can have those available. You can license digital content, assuming you're the copyright holder or you have permission to do so from the copyright holder, and that can offset the cost of digitization. But you never know all of the uses any given file might have. If you're already going to be digitizing something for one purpose, why not do it right so you could use it for any purpose? All right, so now I've made a pretty compelling case for the many reasons you should digitize your collections, and we should probably all go out and digitize everything right now, right? Probably not. Not everything is worth digitizing, and so you'll have to decide what's worth the time, cost, and effort to do so. March's class will be on scope and selection for digitization projects, so I'll go into greater detail then about how to decide which items could and should be digitized at that time. But for now, I'll briefly go over some of the considerations for undertaking digitization projects in general. First, digitization costs money. Whether it's to purchase equipment, paying staff or a vendor to digitize collections, and then to maintain them over time, it's not inexpensive. And to do it right is even more expensive. Digitization is an investment in your collections, not just the initial investment of digitization, but the continued cost of digitally preserving your files. storage space, staff time, it's all worth calculating when making the decision whether to digitize or not, and then to weigh those costs against the alternative. Second, technology changes fast. Hardware becomes obsolete, digital files can easily be changed or erased, either on purpose or on accident, and formats that were once thought to be preservation quality sometimes are not. How many of us have these archival gold CDs in our collections? These, which were meant to last for 100 years, aren't lasting even a portion of that in some cases. In order to maintain digital files for the future, there must be dedication to preserve them over time. That will probably include format migration, as it is not a one and done process. Finally, digitization requires some level of staff time and expertise. Since you're already attending this webinar, I know that you've at least made a small commitment to learning about digitization and how to create lasting, accessible digital collections. Even if you're using a vendor, you'll need to know enough so that you can ask the vendor for the appropriate deliverables and ensure that the end results meet your specifications. And just as technology changes, we'll all need to be kept up to date on new innovations and technologies and how they impact the work we're doing. Thankfully, many new technologies make the work we do easier, but it is an investment all the same. While there are considerations, you'll need to balance the convenience of digital collections with the limitations, the costs with the benefits. Whatever your reason, if you decide to digitize once and use for many purposes. Be sure to digitize to a high enough resolution and supported file format so that you can use that scan over and over, whatever its use. So at this point, we're going to move on to terminology. And the point of this is to really lay the foundation so that in future webinars, we can all agree on what the meaning of is. Understanding the way that we talk about digital objects can help you as you plan to digitally preserve your collections. I know there's a lot of you from all different types of organizations, and the GLAM community has practitioners from all over. Libraries, archives, museums, everywhere. And we want to make sure that we're all using the same language to describe things, especially when we collaborate with partners from different institutional types. These are two great resources, and Becky's going to drop the links for these in the chat. The first one is the federal agency's Digital Guidelines Initiative, more commonly referred to as FADGI, and they have a glossary of terms. The other resource is the Society of American Archivists Dictionary of Archives Terminology. And you'll find some overlap between the two, but the FADGI glossary will focus on more technical terminology, while the SAA dictionary provides many of the more common or conceptual terms. And these are both great resources if you ever feel stuck or you want to just check out and see what something actually is, if you think you know what something is. Okay, great. All right, so let's start with the basics. Analog. Analog is anything that's not digital. Think about a handwritten document, a photograph, a slide negative, or a postcard. Digital. Something that's digital is a signal or data that's expressed in ones or zeros that require a computer to access that information. In the context of the handwritten document, a scan of this document to a PDF file could be its digital counterpart. Last, we have born digital. And this is something that originated in a computer environment, and something that was never analog to begin with. If I decided to type up that first note instead of writing it out by hand or typing it out on a typewriter, the resulting Word document would be born digital. Other examples of born digital include emails, websites, digital photographs, and more. We're going to look at some of the transformative terms. So reformatting or preservation reformatting is copying the information to a new format, either for access or for preservation. And reformatting can look a few different ways. The first way is digitization. This is a type of reformatting where analog signals are recorded into digital form. The signal could either be light or sound emanating from an object. Next is migration, which is also a type of reformatting, but it's more often used for reformatting something in a digital format to a different digital format or carrier. This can be transformative, such as migrating to a new file format, or non-transformative, when the bits are kept intact, but just moved to a different carrier. Once an object has been digitized, there's now an opportunity for more robust metadata. But what is metadata? It's simply data about data or information about information. But good metadata promotes discovery, structures data objects, and supports the administration and preservation of records. Good metadata adheres to certain standards that make it interoperable, so you can share resources both within and across your institutions. Just like with physical records or analog records, the same metadata applies to digital records. Descriptive metadata enables discovery, identification, and selection of resources. It can include elements like title, author, and subjects. There's also administrative data, which facilitates management and control of the files through rights and use elements. But with digital objects, there's also technical and preservation metadata that aids in their management. Finally, there's structural metadata, which describes how files relate to each other, such as pages in a book. We normally think of external metadata, such as a MARC record or a METS XML file, or even a spreadsheet. But once you have a digital file, you can also embed metadata within the file itself that stays with the file wherever it goes. Some embedded metadata is created automatically, like EXIF metadata, that is universal in digital cameras and embeds technical metadata in the image file upon creation. Embedded metadata is beneficial for the user experience. Have you ever opened an MP3 file and the title, band, and album cover all appear? That's coming from metadata embedded in the file. And it's a lot more useful than track 1, track 2, etc. So what do we think of when we think of a file? Formats like TIFF, PDF, JPEG, and more come to mind. These file formats named after the 3-digit suffix that come after the file name, like .tif, .jpg, and .pdf. In these instances, we're actually describing the file's wrapper. Just like a candy bar wrapper, it encapsulates the candy bar, tells you what's inside and its ingredients. We know it's going to be inside when we unwrap that candy bar because of how it's packaged. A file format, which we often refer to as its wrapper, is the set of conventions that define the different elements of a file. The file format defines the bit stream or the data, the embedded metadata, and its wrapper. So now where did these files get stored? We think of digital as being the opposite of physical, when that information is actually recorded physically someplace as electronic impulses. There are many different ways and places to store your files, and you should store your files in more than one of those places. But for now, we'll do a brief overview of the different types of storage media for your digital files. A hard drive, or a local hard drive, is a magnetic storage device designed to provide rapid access to large quantities of data. Think of this as the hard drive in your desktop or laptop computers. Removable media, or removable storage media, is a magnetic storage device designed to store data that can be taken out of its machine. Think of common removable media types: flash drives or thumb drives, external hard drives, optical discs like CDs or DVDs, and magnetic tape. Server is another option. This is a computer configured to store and provide access to files for clients connected via network. This isn't something you would have local access to, but is instead something likely managed by your IT department. Next is the cloud, which is something I'm sure we're all familiar with, but this is used for storing content via the internet rather than locally on a server or a hard drive. It's a bit of a misnomer because the cloud actually does have physical data centers where your data is stored, usually distributed across many locations for redundant and faster access. Examples of cloud storage might be Amazon Web Services, Google Drive, Microsoft Azure. Last is a digital preservation repository. This is a digital repository that takes measures to extend or ensure the viability of its contents. Essentially, these are similar to the earlier examples, but the system is constantly checking its own bit streams and repairing itself in the event of loss or damage. Like with the cloud, these are usually geographically distributed for redundancy. An example of this would be the Michigan Digital Preservation Network's LOCKSS node system, where data is stored across separate nodes and verifies files against other versions of itself and repairs itself when needed. Now we're going to look at different file types. So the first type or group of types is the preservation group. This is the highest quality file created during digitization. This is also called the preservation master, or the archival master, or the archival file, depending on what your organization chooses to call it. These are the files that should have actions taken to ensure their sustainability over time. Production master or mezzanine files are thought to be intermediate files. These are files that are either the same quality as the preservation files or very high quality. And there are two general reasons for creating production or mezzanine files. The first is to compile separate elements into a single file. For example, stitching together digital images from a large map into a single file. Alternatively, you could create a single stereo audio file from a multi-track audio recording. Second, files could be adjusted for aesthetic or technical purposes, such as adjusting tonal levels in a photograph or removing clicks and pops from a digitized recording of a disc. Derivative files are then created from these production masters for an overall better user experience, while leaving the preservation master file or files untouched. Derivative files are files that are derived from higher quality files, such as the preservation or production master files, to serve a particular use. These are most often called access, use, service, thumbnails. This could be an OCR representation of a newspaper, or an MP3 music file, or thumbnail image. Each derivative is optimized for its particular use and is often compressed for smaller, quicker access. This brings us to compression. Compression is when files are reduced to be more easily stored and transmitted. It is not inherently bad to be compressed, but it is important to know about the different types of compression and when each is appropriate. There are a few different flavors of compression. We have uncompressed, losslessly compressed, or lossy compressed. Uncompressed is when none of the information is reduced or removed. These files are usually for preservation master or production master files. Unfortunately, these files are quite large, and so if you have the option, you could select a losslessly compressed file format. Lossless compression is when a compressed file can be decompressed to be exactly the same as it was originally. That way, nothing is lost, not a single bit. For example, the uncompressed version of 100 million is above. The losslessly compressed version is 10 to the 8th. They equal the same thing, but one is represented using far less data. It takes some computing to decompress the 10 to the 8th, but it ends up equaling the same. That's an example of losslessly compressed data. Alternatively, lossy compression compresses files, but one of the ways it does this is by throwing away that information. The information cannot be recovered when the file is decompressed. This isn't necessarily a bad thing. Depending on the environment or the use of the file, that might be appropriate. For example, a TIFF or a WAV file would be far too large to adequately stream on a website. So a compressed JPEG image file or an MP3 music file is used in its place for a better user experience. That provides near instant access versus waiting for a large file to load, if possible. So if we watch this example of a JPEG file being saved over and over again, what we'll notice is the accumulated loss of those compressed elements over time. This isn't an issue for an access file, but it would be catastrophic for a preservation file. You can see all the information that's lost over time. So scanners and cameras are tools used to transform analog images into raster graphics. We're going to be focusing on some of the most common tools for digitization. First, let's look at the flatbed scanner, probably the most ubiquitous piece of scanning equipment in cultural heritage organizations, not to mention offices and homes. These are often fast, simple to use, and can digitize everything from documents to photographic prints to film strips. These scanners range from low to super high quality with price tags to match. Next is the DSLR, or digital single lens reflex camera. These can be extremely versatile, digitizing common formats like the flatbed, plus three-dimensional objects. It can also digitize fragile materials that would be strained or damaged on a flatbed, plus photographic negatives and more. There's a bit of a learning curve when it comes to this equipment, however, and the cost of a good setup can rival that of the most high-end flatbed or book edge scanners. Next is a planetary scanner. These are overhead scanners designed to capture material at very high resolutions. They capture images one line at a time, either by moving the camera or the object. They're very similar to a digital mounted camera, but instead of capturing a raster image at once, these take time and scan the image, scan rows of the image data one by one at very high resolutions to build that image. These are very large and expensive, so you'll often only find them in large institutions or organizations with very specialized, oversized collections. Last, we have the film or slide scanner. These are specialty scanners designed for digitizing film negatives or slides. You can often find models that offer magazines, so you can load up to 50 slides at a time. If you have a lot of slides or a lot of film in your collection, this might be a good choice. When it comes to equipment, there are many options out there, and knowing what you have to digitize will be essential when picking the right equipment for your organization. You'll have cost, ease of use, space, and upkeep to consider. Now that we know what we use to digitize, let's look at the digitized materials. The building block of a digital image is the pixel, which stands for picture element. A pixel is the smallest discrete unit of information in the image's structure. Think of a digital image like a grid, where each square represents a pixel. You can see this from the image of the panda, where the individual pictures are laid out on a grid to represent it. We know what it is, but there's no real sharpness or detail to the image. This image has a low resolution, and the number of pixels in an image determines its resolution. Usually, the higher the resolution, the higher quality the image. In this next image of the panda, you can't even see the individual pictures at this point. The image has a much higher resolution, so there's more sharpness and detail able to be resolved in the image. When you talk about digital objects, resolution is often described in PPI, or pixels per inch. You may sometimes hear DPI, or dots per inch, but this is used primarily for printing, and the dots refer to the dots of ink. So the preferred term is PPI, though you'll hear them used interchangeably. Additionally, when talking about digitization, you might hear the terms optical or interpolated resolution. A scanner might boast of having a very high interpolated resolution, much higher than the optical resolution. Optical resolution is the actual resolution the scanner can capture, where interpolated resolution is the resolution the scanner can create by mathematically filling in pixels to meet a specified resolution, instead of actually capturing at that resolution. You'll always want to base scanner selection on optical resolution rather than interpolated. So if resolution is the quantity or the number of pixels, everything else after this can be considered the quality of those pixels. Pixels are made up of bits. A bit, which is short for binary digit, is the smallest unit of measurement in a binary system. Bits are represented as either a 1 or a 0. I like to think of it as heads or tails of a coin. The number of bits that define each picture is known as its bit depth. The higher the bit depth, the more information can be represented by that pixel. Bit depth ranges from 1 to usually 48, with common bit depths of 1, 8, and 24. Let's take a look at some of the common bit depths for digital images. First one is bitonal, or 1 bit. That 1 pixel can be represented by one of 2 possible values, either black or white, heads or tails. The next is grayscale. Grayscale files are usually 8-bit. That means that there are 2 to the 8th power, or 256 possible values in that pixel, from 0 being black to 255 being white. Next is color. Color files are usually 24-bit, but those 24 bits are divided amongst 3 color channels in an RGB color model: red, green, and blue. So it's really 8 bits per color channel. And if there are 256 possible values for each channel, there are 16,777,216 possible values for each pixel. That's a lot of options. So why don't we take a look at color a little bit closer. What is a color model? It's the way we turn colors into numbers or data. Humans can perceive colors while computers cannot, but they can understand data. There are a few different color mods or models. and the most common of which are RGB and CMYK. RGB stands for red, green, and blue. This is additive, meaning you start with black and add light to create colors, the result of all colors being white. RGB is used for digital photography, computer monitors, websites, etc. Basically, anything you digitize will be set to an RGB color mode. The other common color mode is likely something you're already familiar with. It's CMYK, which stands for cyan, magenta, yellow, and black, with K representing the black. This color model is subtractive. CMYK is used for printing, and I'm sure, or at least I know if this has happened to me, you've designed something on a computer, and when you printed it out, the image colors don't look anything like what you saw on your computer screen. This was likely because you were creating something in an RGB color profile instead of CMYK for printing. In both of these color models, the chroma, or color, and luma, which is the brightness, are combined into the same channels. So when you adjust the red, you're also adjusting the brightness of that red hue. But that isn't always the best way to manage these elements, as the human eye is much better attuned to brightness than it is to color. Because of this, there are other color models where the chroma and luma are separated out into their own channels. The LAB model is used for still images where brightness, or the luminescence value, is separated out from the chroma, or color values. And the color values are on an axis. In the LAB, the L refers to the brightness, A refers to the red-green axis, and B refers to the blue-yellow axis. In video, there are similar modes. There's YUV for analog video, or YCBCR for digital video. The reasons that they started separating out the luma and chroma values was due to the invention of color television. They needed a television signal to appear, whether the receiver was a black and white television or a color television. As you can see in the image on the right, how each of the colors appear in their own channels, as well as the luma value. Last in the color and brightness discussion is dynamic range, or the range of tonal difference between the lightest light, and the darkest dark of an image. The higher the dynamic range, the more potential shades can be represented. This is often seen as a lack of detail in the shadows or highlights in an image. You look at this image, you'll see a lot more of the detail on the image on the right. So what is digital preservation? As I mentioned earlier, digitization is not preservation. Digital preservation is its own process and an integral part of the digital lifecycle. It's a combination of policies, strategies, and actions taken to preserve the accuracy, authenticity, and accessibility of digital records over time. I'll go over a few of the key terms that you'll encounter when practicing digital preservation. First is validation. No, not that kind of validation. Validation confirms that a file conforms to the file format specification. This could be the file itself or corresponding metadata, such as a sidecar XML file. Unvalidated files can still be digitally preserved, but they may require additional steps to access or migrate in the future. It's much easier to prepare for the future than to try to work your way backwards. A word you'll hear a lot in digital preservation is checksum. A checksum is like a digital fingerprint of a file that is completely unique to it. If a single bit changes in that file, it won't have the same checksum. You can use checksums to detect if something has changed within your files, but it won't tell you what has changed. For example, on the right, you'll see two checksums. The top is for the string digital preservation rocks with no exclamation point. Even though it's only a single character difference in the string, the checksum is completely different from the bottom one that does have an exclamation point. It's not just a little bit changed, it's completely changed. These are also examples of MD5 checksums. Checksums come in different flavors, but the most common you'll encounter are MD5, SHA-1, and SHA-256. So you'll use checksums to maintain fixity over time. What is fixity? Fixity is the assurance that something is unchanged. You would do this by generating a checksum when a file is created, so you know how it started. Then you'd regenerate that checksum anytime you moved a file to ensure that the file was successful as it moved. In digital preservation, you also periodically run fixity checks to ensure the files haven't changed in storage. These changes can happen either intentionally or unintentionally. Maybe you have an updated version of a file and you replaced it, but forgot to replace the checksum. Or perhaps someone maliciously altered a file. these would be intentional changes. But how could files change unintentionally? You'll remember earlier when I said that all digital data is made up of bits, right? So these bits or binary digits are just ones and zeros. Sometimes the electromagnetic charge that is used for encoding either 1 or the 0 can decay, leading to the bit to change from 1 to another, to a 0 to a 1, or vice versa. Such a small change might not matter much within an analog world. If paper starts to yellow slightly, we can usually still read what's there. Bit rot and data decay can result in total data loss, which is why bit level fixity is essential for digital objects. So in this example, you'll see the first image is correct. The second image has 1 bit flipped. You can see the change in the image result. The next image has 2 bits flipped, and the last has 3 bits flipped. You can see how much data is lost by even a single or a handful of bits changing. All right, that was a lot of information. Let's go over the key takeaways. There are lots of reasons to digitize: increased access, preservation of material, access to revenue. But digitization is also a commitment. There's cost for equipment, staff time, and technology changes. It's a substantial commitment. If you're going to digitize once and use for many purposes. And if you want to digitize, there are a lot of tools available to help prepare you to digitize your collections. Okay, thank you. I'm coming back with my camera and we are ready to take some questions if you have them. I'm not sure if there were any in the chat, or you can feel free to go ahead and unmute yourself. No questions in the chat, okay. Let's see. Well, I do want to say that I know that some of these concepts are fairly abstract, but they're important to at least have a mild understanding of going forward. Future classes will be mostly focused on step-by-step and instructional base, like how to do specific things. I just really wanted everyone to have an understanding of why they might be digitizing and some key concepts. So we can hang out for a few minutes if people have questions.
Yeah, so this is Kay Schwartz at Flint Public Library, and we have several of our staff on the call today. So I gather, I mean, I learned some new things today. I refreshed on some of the things that I had kind of heard of before. But as we go forward, and you're going to talk to us about, you know, how to actually start out and begin. Some of the things you talked about today, which is, this is what, you know, uncompressed, this is what lossless, this is what lossy is. We're going to get kind of a path to go through that, right?
Definitely.
I mean, you're going to be saying, okay, here, you know, we don't want to use lossy, we do want to use lossless, and here's, you know, now we know what they are, but we're going to actually not have to choose from a lot of these things because there's certain ones of them that are best practice, right? Is exactly. That, I'm just guessing here, I'm hoping, because there were a lot of different choices of things today, so.
Definitely.
Okay.
There will be, so the next class is planning your digitization project. So you'll learn how to make these sorts of decisions, because not everybody's digitization program is going to look the same. People have access to different resources, different technical skills, and there are standards, there are best practices, and then there's going to be what's attainable. So knowing what those are in some of the subsequent classes, you'll be able to make those decisions. So, you know, for image files, if I wanted to have a 4-star FATI file, maybe I would digitize to this resolution TIFF, but I just don't have the storage space for that. So maybe I'm going to do a slightly lower resolution TIFF that still meets my needs. Or sure. Maybe, you know, maybe you're going to do a JPEG 2000 because it's losslessly compressed and it takes up less space, but you still maintain all the information. So yeah, in future classes, there will be a lot more specific how to do things and which formats are available to choose and how to choose those for your collections.
Great, thank you. That sounds great.
Yeah, you're welcome.
Biz, we do have a question in the chat from Heather. What is the best method to digitize a bound book, especially historic local document books that are degrading?
So for a bound book, if you want to keep it bound, something like a digital camera would probably be your best bet. So something that you wouldn't have to put pressure on the binding of the bound volume, but that you could still photograph. So you would get kind of a book cradle to hold the book and then a mounted camera above it so that you can still digitize, but you're not putting any unnecessary pressure on it. Depending on the type of book, if you wanted to disbind the book, you could do that and then put it on a flatbed scanner. It just kind of depends on the fragility of the item, the uniqueness of the item. Does that help?
She says thank you.
Okay, great. Thank you. Okay.
We have another comment here from Jennifer. A digitization policy would be great. Also a sample policy for digital donations as opposed to donations of traditional paper-based materials.
Okay, so in that example, you're talking about if somebody donated digital files to you rather than paper documents. That's great because a lot of times you won't have control over the type of files that you have donated to you. So what you could do, there's a lot of resources out there on what to do with digital archiving of those materials and how to handle those. So I will make a note to make some programming around just digital archiving rather than digitization. So we will be covering digital preservation of files once they've been digitized, but we don't have a lot of content right now on digital archiving of either born digital or receiving those, but there are a lot of parallels. So we'll definitely be sure to include some of that when we get to those classes. All right. Well, if you have any other questions, you can feel free to drop them in the chat or unmute yourself. Otherwise, I'll just kind of button things up right now. Next up is our Planning Your Digitization project. So that will be on February 22nd at 1 p.m. And we hope that you can register for it. Becky will drop the registration link for that in the chat. And I just want to thank you all for coming today. Feel free to reach out to me if you have questions about your specific project or just questions about digitization in general. I'm happy to meet with you. And I really appreciate you coming today and participating. I think last we'll just say thank you. And Becky's also going to drop the survey link in the chat. This project was made possible by the Institute of Museum and Library Services. So we appreciate any feedback you can give to help us improve our programming. Thank you so much.